Hi, and welcome to this second part of our series of videos. It's all about work holding devices to be used on the lathe. In our first video we spoke about 3-jaw chucks, 4-jaw chucks, and collets, and more specifically as far as collets goes, the C series of collets. And well, I spoke a lot about C5 collets. And a few of you out there commented that I was saying it backwards, and true enough, I am saying it backwards. It's not a C5 collet, it's a 5C collet. And I've always said it the wrong way. And since my videos aren't scripted, and even though I wish to mend my ways, I may say it backwards again before the end of this video. We'll see how things work out. It kind of really destroys all my notions of perfection as far as I go. But I realize as I get older that you have to be pretty young to think that you're perfect. And as I get older, well, I'm learning to live with my mediocrity. Another thing that emanated from our first video was a few questions concerning this modified 5C collet. See, I got it right there. That we modified to make a fixture out of to hold a specific part, and people wanted to see it a little closer and maybe have an idea of what that part was for. So come on in a little closer and we'll take a look. So here we have our 5C collet that's been modified on the electrical discharge machine, a die sinking EDM. And you have to remember that with school projects, what matters is really what you learn. It's not how cool the project is. And in this case, well, we learned about fixturing. We learned how to use the EDM, or the students learned, I already knew. And we learned about production a little bit because our part could be inserted in there. I'm not as dexterous as I used to be to machine the nub on the end here, and then turn it around to produce a second one, or an identical one, on the other side by adjusting obviously the saddle's position on the lathe. So we do all of them. We made about 200 of them on one surface, turn around, adjust the saddle, and we did 200 on the other. Now this is part of an assembly that produces a small C-clamp. We can see it right here, and we'll see where that goes in a second. But the body was produced with a punch and die set. So the students learned how to design and produce a punch and die. And all that survives of that die set is this main blanking punch. So we blanked out many, many hundreds of these because they were stacked together. We also produced fixtures to produce these brass ends, and the thread here is a standard 1032 socket head cap screw. Okay, so we have the end here and the drive nut that was produced, and this is the threaded portion, and the two nubs serve to rivet it in place. So you can see here how that goes. So that was our little school project. Now you may remember in the last video that we spoke about these R8 collets, and we mentioned that they're mostly used to hold tools into milling machine spindles. And there's a reason for that, because they could be used on a lathe. It's just that the part's length that you can hold in them is quite limited, because they're drawn into the spindle by an internal thread. On the mill, that's the drawbar in the spindle. And that means that if I used these on the lathe, I'd be limited to parts that are shorter in length than the length of this R8 collet. Quite a bit shorter, because the first third of the collet is occupied by that internal thread. And that's why these aren't used. But that also means that our 5C collets, I got it right that time again, have their drawing or their pulling thread on the outside of the collet, as you can see here. And that means that the center of the collet is open and parts can stick through them and into the spindle of the machine, so you can get quite long parts into these collets, and that's great. But some of you may have noticed that some 5C collets, I got it right, have internal threads as well, and it's important to note that these internal threads are not for clamping purpose. They are for stops and other accessories. So you can insert into a 5C collet a stop that threads into that internal thread. But beware, you have to buy a 5C collet that has that internal thread if you want to use one of those threaded stops. They normally come with just the outer thread. If you want the inner, you have to order them that way. Now, if you are going to use stops on 5C collets to control the depth position and get uniform lengths on your part when surfacing, there's something you need to know. The included angle on the end here seems to be somewhere around 20 degrees total, so 10 degrees per side. And that means that any small difference in the diameter of the part inserted in here will make a big difference as to how deeply this plunges into the spindle of the machine. What does that mean? Well, let's say we had an included angle here of 90 degrees. That would be a ratio of about 1 to 1. So if I inserted a part here that was 1/1000th of an inch smaller than the part that I'd set the depth with, well, that would mean that my clamp would close up 1/2 inch, 1/1000th of an inch more on each side, and my collet would penetrate the spindle by about 1/1000th of an inch. So I would have a 1 to 1 difference, or about there. Now, that doesn't seem like much, but the angle here isn't 90, it's about 20. So a 45 angle, well, that would be about a 2 to 1. And a 20 degree angle, 22.5 really, would be what? A 4 to 1. So that means that when I pull this in, I'm going to have 4 times the difference in diameter. What does that mean? Well, it's pretty simple. If I have a part that's 4/1000th of an inch smaller than the part that I used when I set the depth here, I'm going to have a length that's going to vary by about 16/1000th of an inch. That's why it's important to make sure when you're using these that you keep good control of the diameter of the parts that they're setting into them. But remember, you can only use plus or minus 2. You don't want a big range of dimensions in one collet. So that is a real maximum would be 4 thou on the diameter. But it's something to keep in mind. Okay, I get it. Collets are accurate, but they are very limited. So what's the big advantage other than accuracy that would push me to buy some collets? Because it does get very expensive because they're very limited. Well, there are certain advantages, but before we get into them, I want to say you can get collets in different sizes. You can get collets with round bores, obviously, but you can get some with square or hex bores. And if you can't get the collet specifically that you need to hold the part that you want to hold, well, you can get machinable collets that aren't hardened on their business end, and you can machine into those heads exactly the bore needed to hold your part. So other than precision, what are the advantages? Well, we'll talk about 2, and both are related to RPM. Now, obviously, a collet is quite compact, and depending on the collet holding device that you're using, they are generally quite light and don't consist of a very massive part. That means that they can reach high RPM easily. Now, as long as your machine can get to that RPM. So that is a real plus. They're compact and quite light compared to 3 and 4 jaw chucks. And the second advantage, well, has to do with that also, and that is the size of parts. You don't want to turn a very large part at very high RPMs. So generally, high RPMs are reserved for small parts. Now 3 and 4 jaw chucks are limited as far as how small a part you can hold in them. They're quite limited because their jaws have to meet at the center. And well, knowing that, I think you can figure out that if they can't meet at the center because there has to be a small flat on the end of those jaws, well, you can't hold a very small part. And obviously, the larger the chuck is, the larger the part, the minimum size part is going to be. And collets, well, aren't limited that way. You can hold quite small parts in a 5C collet. The last thing is that you have to remember that 5C collets envelop your part. I mean, they hold on a large surface, and that means that you can get away with holding a part more just on its edge. I wouldn't hold it just by the edge, but you don't need that depth of penetration of the part. Think about it, a 3-jaw chuck holds only on 3 points because its jaws don't come to a point, but they don't have a huge surface there. And that, well, will bite into a part if, well, I apply a lot of cutting force on the part. Whereas the collet chucks, or the collets, well, they touch all around the part. A lot greater contact.
As an example, let's look at a 3/4 of an inch 5C collet and a collet chuck. We're going to mount in the collet a piece of 3/4 of an inch mild cold rolled steel and take some cuts. As you can see here, there wasn't a lot to hold on to.
You can also mix and match. Here I have my 5C spin indexer. Why 5C? Well, because it's bore here, the spindle accepts 5C collets. And well, I can insert my 1-inch 5C collet. And since I have made myself a little go-between here, an accurate 1-inch diameter bored out with a shoulder and this quite large thread, I can assemble that, and that permits me to mount my 3-jaw chuck. And well, there you go.
Another way of holding a part in the lathe is to hold it between centers. Now, for a holding between centers operation, you're going to require a drive plate, a drive dog. You're also going to require a live center. The live center is the center that mounts in the spindle of the headstock, and it's called the live center because it turns with the spindle. You're also going to require a dead center, and the dead center is the center that mounts in the tailstock. It's called a dead center because in old times there were no dead centers that had bearings in them, and that meant that the center mounted in the tailstock did not turn with the part. And well, low RPMs and high pressure grease needed to be used to stop the part from melting away the end of the dead center. However, nowadays we have dead centers with bearings in them, so I tend to call them rotary dead centers. I do expect some flack about this because many people call them live centers because they turn with the part. When you're holding parts between centers, well, you don't have to worry about concentricity, and that's the main advantage. Second advantage, well, is that you can get access to the whole of the outside of the part because you can flip the part end to end at any time as mentioned, without affecting concentricity. Why is that important? Well, with the 3-jaw chuck and the collet, as soon as you move the part, you lose your concentricity. You can't reinstall the part easily or at all concentric to what it was. Now, with collets, it's a lot more accurate, but the 3-jaw chuck, really not very accurate. With a 4-jaw chuck, well, you can move the part quite accurately. You can flip it, you can dismount it, remount it, and always come back to concentric. But as we've seen, that's a lot of work. When turning between centers, the drive dog will come in contact with the pin on the drive plate, and the drive dog that is fixed onto one end of your part will drive the part that's held between centers. So if you want to, you could start by machining one end of the part, do all kinds of operations, whatever is required. And you can even then dismount the part from the machine and head over to another machine, another lathe, or even a milling machine or something of the sort. Perform secondary operations. Then you could even return to the original machine and continue machining, after which, if required, you could dismount the part, remove the lathe dog from one end, install it on the other end of the part, reinstall the part between centers, and machine the second end of the part. And everything that you do between centers will be concentric. That is a real advantage. The only things that you can't really do between centers, well, easily, is surface the ends of the parts and do any drilling, reaming, or boring operations. And when I say boring operations, I don't mean that the operations are, like I am, a little boring. I mean boring operations as in producing concentric holes using single lip cutting tools. Compression holding a part resembles up to a certain point holding a part between centers. We can see here that we have what seems to be a part held between a 3-jaw chuck and a center, but it isn't a part, it's actually two parts, and the part being held between the part held in the 3-jaw and the center, well, is being held in compression. With the fixture that we've just produced, we can show true compression holding by inserting a thin sheet of aluminum between the two halves of the fixture. Now, we can hold the part by compression in this way, and this gives us full access to the outside diameter of the disc that I want to turn. Not only that, it permits to produce a disc that is center hole or hole free. It's really the best way to hold very thin stock that doesn't have a hole through it. And if you plan properly, you can produce a fixture that's just a few thousandths of an inch smaller than the diameter of the part you want to produce, and that will give you great support when cutting. And that's important because one of the major problems with thin parts is material being pushed away from the cutting tool because the part just isn't rigid enough. Here's another example of compression holding a part that we used in our machining a sphere video. Now, if you want to watch the whole video and get the explanations, well, you can click on the link above. And if you like living on the edge, you can use a nest fixture and just the pressure of your hand holding an abrasive cloth or pad to hold the part in the machine for certain polishing operations.
Now, there is no such thing as one single good work holding device for a lathe that'll work for all jobs. No, there are several, and we've seen 4 ways here. The 3-jaw, the 4-jaw, between centers, and collets. And, well, you'll have to choose depending on the part that you want to produce, and more often than not, a combination. If you're producing very long parts, well, you're probably going to want to go between centers. But before you can machine a part between centers, you have to have centers. So some kind of 3 or 4 jaw will be required to hold the part for that. If you want to produce shorter parts, well, chucks can do the trick, 3 or 4. But remember we mentioned 3-jaw chucks are your go-to chucks, so you'll probably start most jobs with them. If you can produce the whole part in the 3-jaw, well, without moving it, you will have a very accurate and concentric part. However, if you do have to move it, you're probably going to move on to a 4-jaw chuck to bring it back concentric before continuing on your machining. And, well, collets fall somewhere between the 3 and the 4-jaw because they are very accurate. So if you're starting off with very accurate stock, well, a collet can have a lot of advantages because it holds easily the part. However, if you're starting with an odd-shaped part or something that isn't standard in dimension or rough, well, you may want to start with a 3-jaw, and when comes the time to flip it over to do the other side, well, maybe then you could use a collet. You see, there's no good answer. What is important is to know what you can get away with each one. So, until we meet again, and I know I lied because I said we'd look at steady rests and follower rests, but I realize that that's going to take a whole other video to look into. So that'll be for another video. So, until we meet again, have fun, be safe, and happy machining.
There you go.